Points on Earth are designated with coordinates, for example with the Geographic Coordination System, a grid of parallels and meridians. For topographical use, a grid is used with X and Y coordinates. We also use this system in archaeology. The Dutch grid system makes sure that the exact location is known of excavations, trenches, features and even single finds. In former times, the 0 point of the grid axis was formed by a church in Amersfoort, a central point in the Netherlands. Because of practical considerations, this changed to a 0 point outside the Netherlands, in this case northern France. To avoid confusion, the X and Y coordinates are never the same, and no negative numbers exist. So, X coordinates in the Netherlands go from 0 to about 300 kilometers, and I coordinates from 300 to 625 kilometers. Most excavations prefer a measurement system of local grid points. With this system, trenches are planned, excavated and documented. The north of the local grid is not always the same as the real north. On site, the most suitable position of the measurement system is chosen. The local grid is always linked with GPS to the national system by at least 2 main grid points. Because of this link, the national reference points of the whole of the excavation are known. The grid is laid out in the trenches with measuring tapes at 3-meter intervals as much as possible. The 0 point is preferably in the southwest of the system. The X-axis runs from west to east and the Y-axis from south to north. The 0 ends of all the tape lines start at the same site. This interval of 3 meters between the tape measures guarantees the quality of the measurements while still maintaining overview of the features. The main grid points are indicated with plastic tubes. In between 2 grid points we fasten a measuring tape with surveyor arrows. The position of the 0 end of a measuring tape depends on the kind of tape. In this case, the 0 end is the flat piece of metal of the end strap. You can always check the position of the 0 end by folding the tape. Unlock the tape. To secure the 0 end, firmly use 1 or 2 arrows. Make sure the 0 end starts halfway the grid point. Walk to the opposite grid point and make sure the tape lies in a straight line. Sometimes you have to pull hard, so tightly securing the 0 end is important. Lock the tape at a convenient measure and wind it around the grid point. Place the tape on the surface and keep it under tension by securing it with 1 or 2 arrows. Degree angles are used to make a local grid. Straight angles can be made with the use of a dumpy level, not very accurate, or a total station. But there are 2 other methods that are more convenient to use on site. The first one is based on the Pythagorean equation. The square root of a plus the square root of b equals the square root of c and concerns the 3 sides of a right triangle. This gives us some simple rules of thumb to set out a right angle. Because the measuring tapes are at a 3-meter interval, we can either use the 3, 4, 5 sequence, the 6, 8, 10 one, or the 9, 12, 15 one. But the bigger the number, the more difficult it is to make an accurate triangle. In this example, we will use the 3, 4, 5 sequence. For this, you need an extra measuring tape and surveying arrows. Fix the 0 end of the extra tape perpendicular at the zero end of the measuring tape that's already in place. Then hold as a varying arrow steady at the 3 meters measure. Of course, this 3 meter point cannot be pinpointed just on the face of it. Unroll the tape 8 meters, which is the sum of the 3 and 5 meter part, and let someone hold this in place on the 4 meters point on the x-axis. Then hold the surveying arrow steady at the 3 meter measure of the 8 meter tape and pull the tape until it's under tension. You will automatically get a right angle. Carefully pin the arrow in the ground. We have now marked a new grid point. The second method to set out a right angle is the rectangle method. Fasten a new measuring tape with zero end at one of the grid points. Unroll the tape to the intended length, in this case 19 meters plus 3 meters, so 22 meters in total. Let someone else hold the 22 meter steady at the grid point of the other parallel stretch of tape. Then hold the surveying arrow steady at the 19 meters of the 22 meters long tape and pull the tape under tension. You will automatically get a right angle. Carefully pin the arrow in the ground. We have yet fixed another grid point.